Hello everybody, this is Mr. McNair, and this is a short video on rational exponents. Now, let's go ahead and review a little bit of vocabulary. First, we have what's called a radical symbol, that is this here. And the number that's under the radical symbol is called the radicand. For example, if we had the square root of 9, the 9 would be called the radicand. All right. Next, we have this term index, and index is a small number to the left of the radical symbol that tells which root to take. All right, so for example, this symbol right here, that's called the cube root or the cubic root. And it's asking what number can I multiply by itself 3 times to get the radicand. Now, this 3, that's called the index. Okay, that's what we were talking about here. It's called the index. All right, so in example 1, let's just move everything up a little bit. In example 1, we have the cube root of 8. So what number can I multiply by itself 3 times and get 8? Well, that value is 2. 2 times 2 times 2 would give you 8. So the answer to this is 2. All right? So here, example 2a. So here we have the square root of 49. Just so that you know, anytime you have a square root and there's no index on it, the index is automatically a 2 because the square root is kind of like the parent function of all of it. All right, so the square root of 49 we have is 7. Fifth root of 0 is our next one. What number can you multiply by itself 5 times to get 0? Well, 0. Here, C, the fourth root of 1,296. Well, what number can I multiply by itself 4 times to get 1,296? That's 6. And D, the negative fifth root of 1,024. Well, the fifth root of 1,024, well, that's 4. And then we're just going to drop down that negative symbol. Okay, so the answer to that is negative 4. All right, another way to write nth roots is by using fractional exponents. A number raised to the power of 1 over n is equal to the nth root of that number. So, for example, all right, we can rewrite the square root of 3 with an exponent. Now, recall that the square root of 3 has an index of what? 2. Okay, so if I wanted to rewrite the square root of 3, that could be rewritten as 3 to the 1/2 power. If I wanted to rewrite the fourth root of 5, that could be written as 5 to the 1/4 power. If I wanted to rewrite the seventh root of 2, that would be 2 to the 1/7 power. Okay? All right. So here we're going to simplify the expressions. 625 to the 1/5 power. Okay, now just so that you know how to type this in your calculator, let's bring that up. So 625 to the 1/5 power. Now, depending on what calculator you have, you might do things differently. These graphing calculators, you hit the caret key, and I generally put my exponent in parentheses. So I believe that was 625 to the 1/5 power. Yes. So our answer is 3.623. Approximately. Okay? Now B. B, we have 25 to the 1/2 power. If you calculated that out, you would know that that was 5. Minus 1 to the 1/4 power. Well, any number that has a base of 1 is going to be 1. So that's going to be 1. And we know 5 minus 1 is 4. All right, great. Moving on. Now, these problems are a little bit different. What we're going to do here is we're going to take this 3/2. All right, and what we're going to do with it is break it up. Okay, we know that 3/2 is the same thing as 1/2 times 3, right? You multiply straight across. 3 times 1 is 3, and then 1 times 2 is 2. Okay? So I can rewrite this as 25 to the 1/2 times 3. Now, based on the fact that I know that, I can also rewrite this as 25 to the 1/2 to the third power. Because when you raise a power to an exponent, you just multiply the exponents together. Well, what's 25 to the 1/2? Well, that's 5. And then I drop down my 3. Okay? And what's 5 to the third? That's 125. And that would be my answer. Okay? Let's do that over here with number 4b. So again, we're going to take that 3/4 power and we're going to break it up. We'll break that up into the 1/4 power. 1/4 times 3. All right. What number, when you multiply it by itself 4 times, could give you 81? Well, that would be 3. And then I'm again going to drop down this 3. So that's 3 to the third. And we know 3 to the third is 27. All right. And that's our final answer on that one. Okay. Next, simplify. All variables represent non-negative numbers. The reason why we usually have non-negative numbers is because when you square root a non-negative number, the answer usually is not real. So that's why they make the stipulation that all variables represent non-negative numbers. So here, I would take this, and we know that when you have an index of 5, that's just like having a power of what? 1/5. So I can rewrite that as x to the 10th, z to the 5th, all raised to the 1/5 power. Now, we could take that 1/5 and distribute it into the parentheses. And whenever you raise a power to a power, you multiply those together. So that would be x to the 2nd, z to the 1st, or just z. All right, and that would be our simplified answer. Same thing in part B. In part B, we have a 4 on the outside here that distributes into the parentheses. So we're raising a power to a power. That's going to be a to the 16th. We multiply those exponents. In B, we'd have b to the 1st. Okay, because 1/4 times 4 is 1. Now, I'm going to drop down my multiplication symbol. And we know that a third and the third root, those actually do what? Those cancel because those are opposites. So we're just going to drop down that b. From there, we're just going to multiply the things that are alike. B times b is b squared. So we have a to the 16th, b to the 2nd. And that's our final answer. All right. Hopefully this video was helpful to you, and have a great day.